Now, we're going to create a script that'll manage our obstacle. We want it to actually change randomly to different sprites. This way it looks different each time it's spawned out. This will also be a good way for us to implement the iRecycled interface that we just used, so that every time a new instance is created, instead of relying on having to instantiate it from scratch, we'll take advantage of the fact that the object pool will automatically call restart and shut down. So every time a new obstacle is restarted, we'll randomly pick a new sprite and display that instead. Let's go into our scripts folder and create a new class called obstacles. And then we'll open this up in MonoDevelop. So the first thing we're going to want to do is implement our interface for iRecycle. We can do this by adding a comma after MonoBehavior and typing in iRecycle. Now, if we were to save this script and go back over to Unity, you'll start seeing an error. If we look at the console, you'll see that obstacles does not implement the interface member iRecycle restart, and we don't implement shutdown. If you remember back to what I was saying about an interface, the interface forces a class to have to implement any of the public methods that are defined in the interface. So in order to get around this error, we're going to need to go back in here and create these two methods. Also, since we're going to rely on restart and shutdown, we can actually delete the start and update since we're no longer going to be using them. Let's create a public void restart method, and let's create a public void shutdown method. Now, we're going to avoid using the awake and start methods that are part of MonoBehavior's normal lifecycle because iRecycle implements its own lifecycle with using restart and shutdown as part of the object pool. Now let's save this script and go back into Unity. We'll see here that the errors have gone away. Let's also go to our prefab and add this script to it. Here we'll filter out for obstacle and add it onto the script. Now let's go back over to the obstacle script and add in the logic to have it change the artwork whenever it gets restarted. First, we'll need to create an array of sprites that we'll use to change the artwork of the obstacle. Next, in our restart method, we're going to want to get a reference to the sprite renderer and pick a random sprite to display. Here, we'll make a variable for the renderer, and we'll get the component of the sprite renderer. The sprite renderer is what actually displays sprites on a game object. Next, we'll want to actually set a random sprite on the renderer itself. Here, we'll get a reference to the renderer we just created, and we'll use its sprite property. Now, we'll need to pick a random sprite. So let's get our sprites array, and from inside of our sprites array, we're going to use the random range method. We'll do 0, and we'll get the length of the sprites array. Now, every time we restart this script, we'll get a random sprite from the array and display it on the renderer. Here, we don't need to worry about shutdown. We're not going to do anything at this point with that. We just need to make sure that we implement it in order to make the compiler happy since we're implementing the iRecycled interface. Let's save our script and go into Unity. Now in obstacles, you'll see that we have an array of sprites. Let's drag some artwork over. One thing we're going to want to do is lock the inspector window by hitting the lock here. This way, when we go through other folders and we select other things, you'll notice the inspector doesn't update. This will let us drag new objects over without losing focus of the prefab that we're already trying to configure. In this case, let's select the crate, the desk, all of the desks actually, the dresser, the trash, and the first TV. Here, we'll drag these over to our sprites array, and you'll notice we'll get a plus sign on the cursor. This means we can now add all these items to the array instead of having to manually configure them by hand. Let's run our game and see if this works. Now, every time a new object gets created, you'll see it has a new graphic. But there's one thing that we're going to have to fix. If we pause this and take a look at each of the objects, you'll notice that the collider is still the same size as how we originally set it up. In the next video, we'll simply clean up the collider, and then our object and object pool system will be complete.